Tonight we drift through a region of space so dark that even the stars seem reluctant to shine. Ahead of you hangs a supermassive black hole, suspended like a tear in the fabric of reality. No surface reflects light. No beacon marks its edge. Around it swirls a glowing disk of gas and dust, heated to temperatures so extreme that entire worlds could vanish inside without leaving so much as a cosmic apology note. You float at a safe distance, watching the strange spectacle unfold. The black hole itself remains invisible. You see it only by what it steals. Stars wander too close and disappear into darkness. Streams of matter spiral inward like water circling a drain. Light bends around the abyss, twisting the background universe into warped arcs and impossible shapes. And yet, as unsettling as this object appears, tonight's mystery is not the black hole. It is something far stranger. A signal. One brief whisper from the depths of space. A signal that arrived without warning. A signal that has never been fully explained. A signal so unusual that when an astronomer discovered it, he circled it in red ink and wrote a single word beside it. Wow. That word became its name. The wow signal. And nearly half a century later, nobody can say with complete confidence what produced it. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're settling in, leave a comment with your location and local time. It's always fascinating to see where on Earth people are listening from while we wander through the universe together. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You continue floating near the black hole. The giant dark sphere seems almost alive, though you know it isn't. Gravity here bends space itself. Time flows differently near its edge. If you could somehow hover close enough, hours for you might become years for distant observers. That is an established scientific fact. Massive gravity alters the passage of time. The universe is full of such strange truths. Black holes were once considered mathematical curiosities. Neutron stars sounded impossible. Dark matter remains invisible. Dark energy appears to dominate the cosmos despite nobody fully understanding what it is. Again and again, reality turns out to be stranger than imagination. Which is why the wow signal remains so compelling. Because it sits at an uncomfortable boundary. Not proven. Not disproven. Simply unexplained. As you gaze into the darkness, imagine the observable universe surrounding you. Hundreds of billions of galaxies, perhaps trillions. Each galaxy containing billions of stars. Many of those stars hosting planets. Many planets potentially possessing oceans, atmospheres, chemistry, possibly even life. The numbers become difficult to grasp. If every grain of sand on Earth represented a star, the cosmic beaches would stretch far beyond imagination. And yet, despite all those opportunities for life, the universe appears strangely silent. Astronomers point giant radio telescopes toward the sky. They listen. Year after year. Decade after decade. Mostly, they hear natural noise. Pulsars ticking like clocks. Quasars blazing across billions of light years. Hydrogen clouds quietly radiating energy. The crackling afterglow of the Big Bang itself. Space is not truly silent. It hums. It whispers. It crackles. It sings in radio frequencies beyond human hearing. Most of these cosmic sounds have explanations. Some took years to understand. Others took decades. A few remain mysterious even now. The wow Signal belongs in that final category. The surprising part is not merely that it was detected. Astronomers discover unusual signals all the time. The surprising part is how perfectly it matched what researchers expected an artificial transmission might look like. Strong, narrow band, distinct from ordinary cosmic noise, brief but remarkably clear, like finding a single footprint on an untouched beach. Not proof someone was there, but enough to make you look twice, or perhaps 100 times. That possibility has haunted generations of scientists. Was it a natural phenomenon? An unusual astronomical event? A reflection from some unexpected source? A human-made signal that slipped through unnoticed? Or something else? Something that crossed unimaginable distances before reaching Earth? You glance once more toward the black hole. Its gravity pulls relentlessly inward. Yet information from beyond its event horizon can never return. That creates one of modern physics' greatest unsolved mysteries. What ultimately happens to information that falls inside? Scientists still debate the answer. The universe seems fond of hiding things. Dark matter hides most of its mass. Black holes hide their interiors. The earliest moments of the Big Bang remain obscured. And perhaps somewhere among the stars, the true source of the wow signal remains hidden as well. You begin drifting away from the black hole now. The glowing accretion disk fades behind you. The surrounding darkness opens into a vast field of stars. Every point of light represents possibility. Every possibility contains questions. One small joke seems appropriate here. If aliens did send the wow signal, they may be wondering why humanity still hasn't replied properly after nearly 50 years. Interstellar customer support apparently operates on very long wait times. The stars continue shining. The galaxy stretches across the darkness like a river of silver dust. Far beyond, hidden among billions of suns, lies the region of space from which the signal appeared to arrive. A location that has inspired speculation, skepticism, excitement, and debate for generations. For now, you know only 3 things. First, the signal was real. Second, it was unusual. Third, nobody has completely solved the mystery. And as your journey through the cosmic night begins, those 3 facts are more than enough. Because the deeper you travel into the story, the more you discover that the signal itself may be only the beginning. Beyond it waits a larger mystery. A mystery involving stars, galaxies, dark matter, black holes, and perhaps the strange silence of the universe itself. The question is no longer merely what produced one brief burst of radio energy. The question is what that burst reveals about the cosmos we inhabit, and whether, somewhere in the immense darkness between the stars, something may be listening too. You continue drifting outward through the darkness, leaving the black hole behind. Its immense gravity still lingers in your thoughts, a reminder that the universe often reveals itself only indirectly. You never truly saw the black hole itself. You saw the effects it had on everything around it. In a curious way, the story of the wow signal begins the same way. Not with seeing, with listening. Long before humanity could send spacecraft beyond the planets, before images arrived from distant worlds, astronomers discovered that the universe communicates through many forms of light. The visible colors your eyes can detect represent only a tiny fraction of a much larger electromagnetic spectrum. Radio waves stretch far beyond the red end of visible light. They travel enormous distances. They pass through dust clouds that block ordinary starlight. They carry information across the galaxy. If the universe were an orchestra, Visible light would be only one instrument. Radio astronomy opened the door to hearing the entire symphony. As you drift through space, imagine Earth below. A small blue world circling an ordinary star. Tiny by cosmic standards. Yet from that world came a remarkable realization. The sky was not silent. In the early 20th century, engineers investigating strange interference in radio communications began detecting signals that seemed unrelated to anything on Earth. One of them was a young radio engineer named Karl Jansky. While studying sources of radio noise in the 1930s, he discovered something astonishing. A faint hiss appeared every day, not according to Earth's clock, not according to human schedules, according to the stars. The signal originated from the direction of the center of the Milky Way. Humanity had accidentally discovered radio emissions from space. An entirely new window on the universe opened. The observation was surprising because nobody had expected the galaxy itself to be producing detectable radio waves. Suddenly, astronomers possessed a new sense. Not sight, hearing. And what they heard transformed astronomy forever. As decades passed, radio telescopes grew larger, more sensitive, more sophisticated. Massive dishes appeared across deserts, valleys, and remote plains. They listened for whispers arriving from unimaginable distances. Some discoveries were extraordinary. Astronomers found pulsars, rapidly spinning neutron stars that emit beams of radiation like cosmic lighthouses. When pulsars were first detected in 1967, their precisely repeating signals seemed so unusual that researchers jokingly labeled one source LGM-1, Little Green Men 1. For a brief moment, even serious scientists wondered whether the signal might be artificial. It wasn't. It turned out to be a natural object more fascinating than anyone had imagined. A city-sized stellar corpse spinning through space. The universe had once again proven capable of producing phenomena stranger than fiction. That lesson would become important later. Not every mystery has an intelligent source. But not every mystery immediately reveals a natural explanation either. You continue traveling through the stars. The Milky Way surrounds you now. Its spiral arms stretch across hundreds of thousands of light years. Clouds of gas glow faintly in the distance. Clusters of newborn stars illuminate vast nebulae. Between them lie enormous regions of emptiness. Space is far less crowded than most people imagine. If the sun were the size of a coin, the nearest star would still be hundreds of kilometers away. The galaxy is mostly silence, mostly darkness, mostly distance. And yet radio waves cross those distances effortlessly. A transmission sent from one star system could travel for centuries, or thousands of years, or longer, still moving, still carrying information, still waiting to be received. This possibility inspired a profound question. If intelligent civilizations exist elsewhere, how might we detect them? One answer seemed obvious. Listen for radio transmissions. Beginning in the mid-20th century, scientists launched systematic searches for signals that might indicate technological civilizations. The effort became known as the Search for Extraterrestrial Intelligence, or SETI. The idea was surprisingly practical. Radio waves require relatively little energy compared to many alternatives. Certain frequencies travel efficiently through interstellar space. A civilization hoping to announce its presence might naturally use them. Or perhaps humanity might accidentally intercept a signal never intended for us, like overhearing a distant conversation through an open window. No assumptions about alien biology were necessary. No flying saucers. No dramatic invasions. Simply physics. Simply communication. Simply listening. One light joke drifts through your thoughts. Searching for extraterrestrial intelligence is a bit like checking your inbox every day for decades and finding mostly spam from pulsars. Yet scientists persisted. Because the stakes were enormous. Even a single confirmed signal would change humanity forever. It would answer one of the oldest questions ever asked. Are we alone? As the years passed, researchers identified a particularly interesting radio frequency. Around 1420 MHz lies a signal naturally emitted by neutral hydrogen. Hydrogen is the most abundant element in the universe. Stars form from it. Galaxies contain vast quantities of it. Life itself depends upon it. Some scientists proposed that advanced civilizations might recognize this frequency as a universal meeting place on the cosmic radio dial. A frequency any technologically capable species would likely discover. A kind of galactic landmark. Not because someone designated it. Because nature did. This region became known informally as part of the water hole, a quiet area of the radio spectrum where interstellar communication might be practical. The name itself carried a charming image. Animals gathering around a watering hole. Civilizations gathering around a shared frequency. Whether that vision reflects reality remains unknown. But it shaped decades of listening. You pass through a sparse region between stars. The darkness deepens. Ahead lies a giant radio telescope. Its enormous structure sits beneath Earth's sky in the late 1970s. Researchers monitor incoming signals. Computers process streams of data. Most observations prove unremarkable. Natural sources. Background noise. Routine measurements. Nothing that would alter history. At least not yet. Because one summer night, among countless pages of computer printouts, a pattern would appear. A pattern unlike anything previously seen. A sequence so unusual that it would capture attention immediately. Not because it answered humanity's greatest question, but because it hinted, however briefly, that an answer might exist. And here another unresolved mystery quietly emerges. The more humanity learns about the cosmos, the stranger the silence becomes. The galaxy contains billions of potentially habitable worlds. Many stars are older than the sun. Some planetary systems had billions of years of head start before Earth even formed. So where is everybody? No one knows. Perhaps intelligent life is rare. Perhaps civilizations are brief. Perhaps communication is harder than expected. Or perhaps the universe is speaking in ways we do not yet recognize. The wow signal sits directly at the center of that uncertainty. A single unexplained event. Neither proof nor dismissal. A question mark suspended among the stars. And as you approach the summer of 1977, drifting toward a quiet observatory beneath the night sky, you can almost feel the moment approaching. One burst. 72 seconds. A few characters printed on paper. And a mystery that would endure for generations. The year is 1977. You descend gently through the night sky above Ohio, where a giant instrument quietly listens to the universe. Unlike the towering dish-shaped telescopes that many people imagine, this observatory looks surprisingly ordinary at first glance. The instrument is known as the Big Ear, a radio telescope operated by researchers at Ohio State University. Night after night, Big Ear scans the heavens. Not dramatically, not heroically, just patiently. Astronomy often works that way. The universe rewards persistence more than excitement. Most observations produce exactly what scientists expect: background radio noise, known cosmic sources, and long columns of data that appear about as thrilling as tax paperwork from another galaxy. Yet hidden inside those endless streams of information are occasional surprises. And sometimes a surprise becomes a legend. You watch as Big Ear performs its steady sweep across the sky. Because Earth rotates, the telescope does not track objects the way many modern instruments do. Instead, the sky slowly drifts overhead. A radio source enters the telescope's field of view. It grows stronger, then weaker, then disappears. This gradual rise and fall is exactly what astronomers expect from a genuine signal arriving from space. The telescope records everything. Computers convert incoming radio measurements into rows of letters and numbers. Sheets of paper emerge from printers. The data accumulates. Nobody notices anything unusual that night. The moment passes. The universe continues turning. Weeks later, a volunteer astronomer named Jerry Emmons sits down to review the printouts. Page after page contains routine information. Then suddenly he sees something extraordinary. A short sequence stands out from the surrounding data. 6EQUJ5. At first glance it looks meaningless, like a password forgotten by the cosmos. But to radio astronomers, those characters represent signal strength. The sequence indicates a remarkably powerful radio source, far stronger than the background noise surrounding it, far stronger than expected, strong enough to demand attention. Emmons circles the sequence with a red pen. Beside it he writes a single word: "Wa." And just like that, one of astronomy's most enduring mysteries receives its name. You hover over the printout as if looking across time itself. The famous red circle remains one of the most recognizable images in the history of SETI. What made the signal so unusual? Several things. First, it appeared near the hydrogen frequency that researchers considered especially interesting for interstellar communication. Second, it was extremely narrowband. Natural cosmic radio sources usually spread energy across broader ranges of frequencies. A narrowband signal often suggests some organized process. Not necessarily intelligence, but something unusual. Third, the signal behaved exactly as a distant source should. It gradually strengthened as it moved through the telescope's observation window and then gradually faded. This matched the expected pattern for a genuine astronomical origin. That fact remains important. The signal did not look like a simple equipment malfunction. It looked real. And that is where the mystery begins, because it was never detected again. You drift higher above Earth. Clouds slide beneath you. Cities glow softly on the night side of the planet. Meanwhile, scientists begin investigating. Could the signal have originated from Earth? Could it have come from a satellite? Could military equipment have produced it? Could an aircraft be responsible? Researchers examine possibility after possibility. Nothing fits perfectly. The surprising observation is that despite decades of increasingly sensitive searches, no exact repeat of the signal has ever been confirmed from the same location. If it were a continuous beacon, astronomers expected to hear it again. They did not. If it were a common natural phenomenon, similar events should perhaps appear more frequently. Yet the signal remained stubbornly unique. One cosmic whisper. Then silence. A light joke drifts through your thoughts. The universe managed to leave humanity on read decades before social media existed. You continue following the signal's apparent path. It seems to originate from a region near the constellation Sagittarius, in the direction of the Milky Way's crowded central regions. This area contains vast numbers of stars, dense clouds of gas, complex astronomical activity, potentially countless planetary systems. Unfortunately, the telescope's design prevented researchers from pinpointing the exact source. The signal could have originated from one of two nearby regions in the sky. That uncertainty complicated future investigations. Imagine hearing a single knock on your front door. When you open it, nobody is there. You search the street. You search the neighborhood. Years later, you still do not know who knocked. That captures part of the frustration surrounding the wow signal. Not because the evidence was weak, but because it was brief. Brief mysteries are often the hardest to solve. The signal lasted about 72 seconds. That duration was determined not by the source itself but by how long it remained inside the telescope's observing window. If the source continued transmitting afterward, Big Ear would not have known. The telescope had already moved on. And so the crucial question remains unanswered. What happened next? Did the source stop transmitting? Did it continue forever? Was it a one-time event? A repeating phenomenon? An accidental burst? Nobody knows. As the years pass, scientists revisit the data repeatedly. Some researchers propose natural explanations. Others remain unconvinced. Some speculate about comets, though debates continue over whether such explanations fully account for the signal's characteristics. Others explore rare astrophysical processes. None have achieved universal acceptance. Importantly, mainstream science does not consider the wow signal evidence of extraterrestrial intelligence. Evidence requires confirmation, repetition, verification. The signal provides none of those. Yet mainstream science also cannot completely explain it away. The mystery survives precisely because certainty remains out of reach. You find yourself once again surrounded by stars. The radio telescope fades into the distance behind you. The famous printout disappears into history. But the question remains. One genuine signal. One remarkable observation. One brief moment when the universe seemed to raise a finger and say, "Pay attention." And perhaps the strangest part is this. The signal itself may not be the greatest mystery. The greater mystery may be why it stands so alone. Because if one unexplained whisper emerged from the darkness, what else might be hidden there? What other signals have come and gone unnoticed? What rare phenomena await discovery? And how many cosmic stories have already crossed Earth, unheard by anyone at all? The stars offer no answer. Only distance. Only silence. Only the lingering memory of a red circle around 6 strange characters. 6EQUJ5. A tiny mark on a sheet of paper. And one of the deepest mysteries in modern astronomy. After the excitement of discovery comes something less dramatic but far more important. The search. A mystery in science is not solved by wonder alone. It is solved by evidence. And so, in the years following 1977, astronomers begin doing what astronomers do best. They keep looking. You drift forward through decades of scientific effort. The radio telescope in Ohio continues observing. Researchers analyze old records. New instruments join the hunt. Computers become faster. Receivers become more sensitive. Entire generations of scientists inherit the question. What created the wow signal? At first, many hope the answer will arrive quickly. Perhaps another observation will reveal the source. Perhaps the signal will repeat. Perhaps a natural explanation will emerge within a few years. Instead, the mystery grows older and stranger. You float above Earth as radio telescopes around the globe turn toward the sky. Gigantic dishes sweep across the stars. Arrays of antennas listen to distant regions of the Milky Way. Signals pour into computers by the billions. Most prove entirely ordinary. Some are unusual. A few are initially baffling. But none perfectly match the famous event from 1977. That absence becomes part of the mystery itself. A surprising observation emerges from astronomy's long history. Many of the universe's strangest discoveries eventually repeat. Pulsars repeat. Fast radio bursts repeat in some cases. Variable stars repeat. Black holes repeatedly interact with surrounding matter. Patterns are the scientist's best friend. The wow signal refuses to cooperate. It appears once, then vanishes. Imagine spotting a lighthouse flash on a distant horizon. You wait for the next pulse. Nothing. You wait another hour. Nothing. You return the next night. Still nothing. Eventually the question becomes larger than the flash itself. What kind of lighthouse flashes only once? You continue drifting through the galaxy. Nebulae glow softly around you. Star clusters glitter like islands in a cosmic ocean. Some stars are newborns. Others are ancient. Many possess planets. Today we know that planets are common throughout the Milky Way. This is an established scientific fact. When the wow signal was detected, astronomers had not yet confirmed a single planet around another sun-like star. Now thousands have been discovered. Entire planetary systems appear everywhere researchers look. Some worlds orbit twin suns. Some circle red dwarfs. Some may possess oceans beneath icy crusts. Others are scorched infernos. The universe has proven far more inventive than anyone expected. And that realization makes the wow signal even more intriguing. Because every newly discovered planet expands the range of possible origins. Not necessarily intelligent origins. Simply possible origins. You pass through a vast molecular cloud where future stars are forming. The cloud stretches across light years of darkness. Inside, gravity slowly gathers gas together. New solar systems will eventually emerge. Perhaps some will host life. Perhaps none will. Nobody knows. That uncertainty sits at the heart of modern astronomy. Life appeared on Earth surprisingly early in our planet's history. As soon as conditions became suitable, biology seems to have gotten to work. Some scientists view this as encouraging. Maybe life forms readily wherever circumstances allow. Others urge caution. A sample size of one planet tells us remarkably little. Earth may be common. Earth may be rare. Both possibilities remain on the table. And so the search continues. One light joke seems appropriate here. Humanity has spent decades searching for alien intelligence while still occasionally losing Wi-Fi inside the same building. The cosmos can be humbling. As you travel onward, another possibility emerges. What if the signal was natural? This idea has attracted considerable attention. After all, nature has repeatedly surprised astronomers. Pulsars once seemed impossible. Quasars looked absurdly powerful. Black holes sounded almost fictional. Fast radio bursts baffled researchers for years. Maybe the wow signal belongs in that category. a rare astrophysical phenomenon not yet fully understood. Scientists have explored numerous candidates: interstellar gas clouds, rare radio emissions, reflections, instrumental effects, comets passing through the region. Each proposal explains some features. None explains everything to everyone's satisfaction. That distinction matters. In science, an explanation is strongest when it accounts for all available evidence. Partial explanations are useful, but mysteries survive in the gaps. You drift toward the crowded heart of the Milky Way. Stars become more numerous. The sky grows brighter. The galactic center contains a supermassive black hole called Sagittarius A star. Its mass equals roughly 4 million suns. Despite its enormous influence, it remains relatively quiet compared with the giant black holes found in some active galaxies. Yet even a quiet galactic center is a place of extraordinary activity. Magnetic fields twist through space. Gas clouds collide. Stars orbit at tremendous speeds. Exotic phenomena unfold continuously. The region reminds you that the universe possesses countless mechanisms still being studied. A signal need not come from intelligence to be astonishing. Sometimes nature itself is astonishing enough. And yet another unresolved mystery lingers. If the signal was natural, why has no identical event been conclusively identified since? That question remains difficult. The longer astronomers search without finding a perfect match, the more unusual the event appears. Not necessarily more mysterious, but more isolated. Science dislikes isolated events. Repeatability provides confidence. Without repetition, uncertainty remains. As the decades pass, improvements in technology only sharpen the puzzle. Modern radio telescopes are vastly more capable than those of the 1970s. They monitor wider regions of the sky. They record enormous amounts of data. They detect signals that earlier instruments would have missed entirely. And still the wow signal sits alone in the historical record. One brief burst. One unforgettable observation. One unanswered question. Ahead of you stretches the wider galaxy. Hundreds of billions of stars. Countless planets. Unseen objects wandering interstellar space. Invisible dark matter shaping the motions of everything. The deeper you look, the more the mystery expands. Because solving the wow signal is no longer merely about one transmission. It is about understanding what kinds of phenomena exist in the universe. Known phenomena, unknown phenomena, and perhaps entirely unexpected phenomena. The signal begins to feel less like an isolated puzzle and more like a doorway. A doorway leading toward larger questions about the galaxy itself. Questions about what hides in the darkness between stars. Questions about what remains invisible even to our most powerful instruments. Questions about whether the cosmos contains structures and processes we have not yet imagined. And as you move farther into the galactic night, the original mystery quietly transforms. The source of the signal still matters. But now another question emerges. What if the universe is far stranger than the signal? What if the signal is merely a glimpse of a much larger unknown? That possibility waits ahead, beyond familiar astronomy, in the frontier where observation ends and deeper mysteries begin. You leave the crowded regions of the Milky Way behind and continue outward into the galactic ocean. The stars begin to thin. The glowing bands of gas become more distant. Darkness grows deeper between the islands of light. It is here, among the enormous spaces separating one stellar neighborhood from another, that the scale of the wow Signal becomes easier to appreciate, not easier to explain, just easier to feel. A radio signal crossing interstellar space must survive a remarkable journey. Imagine a single ripple traveling across an ocean larger than anything the human mind evolved to comprehend. That ripple encounters gas clouds, magnetic fields, radiation, gravity, countless opportunities to weaken or scatter. And yet radio waves are astonishingly resilient travelers. An established scientific fact is that radio signals can traverse vast stretches of the galaxy with relatively little absorption compared to many other forms of electromagnetic radiation. That property is one reason radio astronomy became such a powerful tool. The cosmos may be unimaginably large, but radio waves can carry whispers across the dark. You drift past a red dwarf star. These small stars are the most common type in the Milky Way. Many are billions of years older than the Sun. Some will continue shining long after our own star has faded. Around them orbit planets by the trillions. This realization would have stunned astronomers of previous generations. When the WOW signal appeared in 1977, humanity had no confirmed evidence of any worlds beyond our solar system. Today, the galaxy looks crowded with possibilities. And that changes how you view the mystery. The signal no longer seems like a message arriving from an empty universe. It arrives from a cosmos overflowing with destinations. You continue onward. Ahead lies a planetary system unlike anything found in school textbooks. One planet circles two stars. Another appears covered in global oceans. A third experiences temperatures hot enough to melt metals. The surprising observation is that many of the strangest worlds imagined in science fiction turned out to be relatively ordinary by cosmic standards. Reality proved more creative than fiction. Astronomers discovered planets larger than Jupiter orbiting incredibly close to their stars. They found worlds where iron may fall as rain. They identified planets wandering through space without any parent star at all. Every decade expands the catalog of the bizarre, and every discovery quietly reminds you that assumptions can be dangerous. The universe rarely consults human expectations. This lesson becomes important as you think about the WOW signal. Perhaps the source was intelligent. Perhaps it was natural. Perhaps it belonged to a category not yet recognized. History offers many examples of unexpected answers. Pulsars are one example. Fast radio bursts are another. As you travel deeper into space, faint flashes appear around you. Brief, powerful, mysterious. These represent fast radio bursts, among the most fascinating discoveries of modern astronomy. Fast radio bursts are real astronomical events that release enormous amounts of energy in milliseconds. Some repeat. Some do not. Their origins remained mysterious for years. Even now, researchers continue studying them. Certain examples appear linked to highly magnetized neutron stars called magnetars. Others remain less clear. The important point is not that fast radio bursts explain the WOW signal. They do not. The important point is that nature continues producing radio phenomena capable of surprising experts. The universe still has secrets. Lots of them. One light joke floats through the darkness. Every time astronomers think they have categorized everything, the universe quietly opens a new folder labeled Miscellaneous. You pass through a stellar graveyard. Ancient stars have already completed their lives here. White dwarfs cool slowly in the darkness. Neutron stars spin silently. Black holes drift unseen. The region feels peaceful, almost timeless. Yet even here mysteries multiply. Take black holes. You remember the giant one from the beginning of the journey. Scientists understand many aspects of black hole behavior remarkably well. General relativity predicts their gravitational effects with extraordinary accuracy. Astronomers have photographed the shadows of supermassive black holes. They have observed stars orbiting invisible masses. They have detected gravitational waves from black hole mergers. And still nobody fully understands what happens to information that falls inside. That unresolved mystery remains one of physics' greatest challenges. The more you learn, the more you discover hidden questions beneath familiar answers. The wow signal follows a similar pattern. At first glance it appears simple. A radio transmission. A strong one. An unexplained one. But beneath that simplicity lies a web of deeper uncertainties. How common are rare radio events? What processes remain undiscovered? Could unusual astronomical conditions create signals we have never seen before? How many phenomena appear only once every century? Or once every million years? The universe has existed for nearly 13.8 billion years. Human radio astronomy occupies only a tiny fraction of that history. You have been listening for mere moments compared with cosmic time. Imagine standing beside a forest for 10 seconds and concluding that no birds live there because none happened to sing during your visit. The conclusion would be premature. Likewise, the universe may be performing countless rare acts beyond our current observations. You move farther from the galactic center now. The Milky Way spreads beneath you like a luminous spiral city. Its billions of stars glow softly in the darkness. Around the galaxy lies something even stranger. An invisible halo of dark matter. Dark matter cannot be seen directly. It does not appear to emit, absorb, or reflect light. Yet its gravity influences galaxies on enormous scales. Astronomers infer its existence because visible matter alone cannot explain observed motions. This is another established scientific fact. Most of the matter in the universe appears to be invisible. Think about that for a moment. Everything familiar, stars, planets, oceans, mountains, people, represents only a small fraction of the universe's total matter content. The majority remains unseen. That realization carries a strange comfort. If most matter is hidden, perhaps we should not be surprised that mysteries remain. The cosmos still contains entire categories of reality that we barely understand. And perhaps that is where the story begins to shift. The wow signal started as a question about a single event. Now it points toward larger questions. Questions about hidden structures, hidden processes, hidden regions of reality. Because if most matter is invisible, what else might remain concealed? Not necessarily civilizations. Not necessarily messages. Simply unknowns. The universe has revealed enough surprises to make humility a sensible strategy. Ahead, the darkness deepens further. Beyond the familiar stars waits an even larger mystery. Not merely what produced one signal, but whether the visible universe itself represents only a thin surface above something far deeper. Something we are only beginning to detect. Something that shapes galaxies, bends light, and influences cosmic history while remaining almost entirely hidden from view. The signal fades into the background for a moment, because now the journey is carrying you toward the invisible architecture of the cosmos itself. And compared to that mystery, even the wow signal may be only a small clue. The farther you travel, the less the universe resembles the picture painted by ordinary experience. On Earth, most things can be seen. Mountains, clouds, rivers, trees. Even when something is hidden, you usually know where to look. But on cosmic scales, much of reality appears to operate behind a curtain. You now drift far beyond the bright spiral arms of the Milky Way. Below you, the galaxy glows like a luminous whirlpool suspended in blackness. Its stars form only the visible portion of a much larger structure. An invisible framework surrounds it, a framework astronomers call dark matter. You cannot see it. No telescope has photographed it directly. Yet galaxies behave as though it exists. Without it, many galaxies would spin so rapidly that their outer regions should fly apart. Instead, they remain intact. Something unseen appears to be holding them together. This is one of the great scientific mysteries of modern astronomy. And it changes how you think about the wow signal. Because once you accept that most matter may be invisible, the universe becomes a much stranger place. Not stranger in a supernatural sense. Stranger in a scientific sense. Reality itself appears incomplete. You continue drifting outward. Around the Milky Way stretches a halo of unseen mass. Beyond that lie neighboring galaxies. And beyond those, vast clusters containing thousands of galaxies bound together by gravity. The cosmic web begins to emerge. Filaments of matter span unimaginable distances. Galaxies gather along these structures like dewdrops on invisible threads. Between them lie enormous voids. Regions so empty that traveling across them would feel like crossing an ocean of almost pure nothingness. The surprising observation is that the largest structures in the universe resemble a network. Not a random scattering. Not complete chaos. A kind of architecture. A cosmic skeleton. And nobody fully understands why the universe took this particular form. Scientists can model much of it using dark matter and gravity. But dark matter itself remains unidentified. Its true nature is still unknown. You pass through one of the great voids now. The darkness becomes profound. Stars grow scarce. Galaxies appear as distant islands of light. The emptiness feels almost physical. Yet even here mysteries accumulate. One of the strangest discoveries in astronomy emerged only in the late 20th century. Researchers studying distant supernovae found evidence that the expansion of the universe is accelerating. Not slowing down. Accelerating. This observation shocked astronomers. Gravity should gradually slow cosmic expansion. Instead, something appears to be pushing space apart. Scientists call this unknown influence dark energy. The name sounds dramatic. In truth, it is a label for something not yet understood. Dark energy may represent one of the deepest mysteries in all of science. Current evidence suggests it constitutes most of the universe's total energy content. Think about that. Most matter appears invisible. Most energy appears mysterious. And humanity lives within a tiny visible fraction of the whole. Suddenly the wow signal feels different. Not smaller, but more contextualized. A puzzle inside a universe already overflowing with puzzles. One light joke drifts through your thoughts. The universe sometimes resembles a textbook where 80% of the pages are missing, and the remaining pages keep introducing new characters. You continue onward. Ahead appears another class of mystery. Rogue objects. Lonely wanderers. Worlds without stars. Black holes moving through darkness. Ancient stellar remnants crossing interstellar space. The galaxy is not neatly organized. It contains travelers. Nomads. Objects moving silently through regions few instruments ever examine. Could rare interactions among such objects create unusual radio emissions? Possibly. Scientists continue exploring possibilities. Importantly, this remains speculation. Observations come first. Hypotheses follow. The distinction matters. One of science's greatest strengths is its willingness to admit uncertainty. The wow signal remains unresolved not because scientists ignore it. It remains unresolved because evidence remains incomplete. That honesty can feel unsatisfying, but it is also powerful. A mystery survives until the data becomes strong enough to resolve it. Not before. You drift past a neutron star. The object is barely 20 kilometers wide, yet it contains more mass than the Sun. Its magnetic field is extraordinarily powerful. Its gravity is immense. The star rotates rapidly, emitting bursts of energy. Nearby space crackles with invisible activity. Neutron stars remind you that the universe often hides extraordinary behavior inside seemingly simple objects. Likewise, a brief radio signal may conceal a surprisingly complex origin, or perhaps a surprisingly simple one. History contains examples of both. As the journey continues, another idea begins to emerge. Suppose the wow signal was not unique. Suppose it belonged to a broader class of events that humanity has rarely observed. That possibility becomes increasingly plausible when you consider how little of the universe has actually been monitored continuously. Most of the sky is not observed at all times. Most frequencies are not recorded constantly. Many transient events may come and go unnoticed. Astronomy has entered an era of time-domain science precisely because researchers increasingly recognize this fact. The sky changes. Sometimes dramatically. Sometimes briefly. The cosmos is not static. It flickers, explodes, collides, erupts. Signals appear and disappear. Entire categories of transient events have been discovered only in recent decades. Who knows what remains hidden? That question leads naturally toward a bigger mystery. Not merely hidden events. Hidden possibilities. You now find yourself looking across billions of light years. Galaxies stretch toward the horizon of the observable universe. Some of their light began traveling before Earth existed. Some departed before the Sun formed. Some started its journey before the Milky Way reached its current shape. Cosmic history unfolds before you like an enormous tapestry. And yet, despite all this grandeur, a peculiar silence remains. The universe is active, violent, dynamic, full of energy. But intelligence, at least detectable intelligence, appears absent, or invisible, or quiet. Nobody knows which. The wow signal occupies an uncomfortable position within that silence. Too unusual to ignore. Too limited to confirm. A single footprint without a traveler. A single note without a song. A single knock without a visitor. And now the mystery expands again. Because once you begin asking whether the signal came from intelligence, you inevitably confront a larger question. Where is everybody? The galaxy is old. The stars are numerous. Planets appear common. The ingredients for life seem widespread. Yet no confirmed evidence of another technological civilization has emerged. Not yet. That puzzle is known by many names, but its essence is simple. A universe that seems capable of producing life appears surprisingly quiet. The deeper you travel into cosmic darkness, the harder that silence becomes to ignore. And beyond it waits an even more unsettling possibility. Perhaps the greatest mystery is not the signal. Perhaps the greatest mystery is the silence surrounding it. You drift through a darkness so vast that entire galaxies appear as scattered sparks. The Milky Way is now only one among countless others. Ahead stretches the observable universe, a sphere nearly incomprehensible in scale, filled with hundreds of billions of galaxies and perhaps far more. Every galaxy contains stars. Many stars contain planets. Many planets possess chemistry. And somewhere within that staggering abundance, the question continues to echo. Where is everyone? The wow signal hangs in your thoughts like a distant bell that rang once and never again. Not proof. Not disproof. Just a lingering note in the cosmic silence. And the silence itself has become the larger mystery. You float above an immense web of galaxies. The structure resembles a network of glowing rivers connected across billions of light years. Astronomers call this the cosmic web. It is among the largest known structures in existence. Galaxies gather along invisible filaments shaped largely by dark matter. The observation is remarkable. If you could step outside the universe and view its large-scale structure, it would not resemble a random spray of stars. It would look more like a vast interconnected framework, a hidden architecture, an invisible scaffold. Dark matter appears to provide much of that scaffold. Yet nobody knows exactly what dark matter is. Scientists have proposed many possibilities. New particles, exotic forms of matter, entire families of particles not yet discovered. Experiments continue around the world. So far, no definitive answer has emerged. That unresolved mystery matters because dark matter dominates the gravitational landscape of the universe. Galaxies grow within it. Clusters form because of it. Light bends around it. Reality itself seems partially governed by something we cannot directly observe. The realization feels almost poetic. You live inside a universe whose visible components may represent only a small fraction of what actually exists. And if that sounds strange, things become stranger still. You continue outward. Ahead lies a galaxy cluster so massive that its gravity bends the path of light itself. Distant galaxies appear stretched into arcs. Some appear duplicated. Others seem distorted into impossible shapes. This phenomenon, known as gravitational lensing, is an established scientific fact predicted by general relativity. Mass curves spacetime. Light follows those curves. The universe acts as its own optical instrument. Sometimes entire galaxies become lenses. Sometimes clusters of galaxies magnify even more distant objects. Nature builds telescopes out of gravity. The surprising observation is that some of humanity's most powerful astronomical discoveries depend on these cosmic lenses. Without them, certain ancient galaxies would remain invisible. The universe occasionally helps us observe itself. You smile at the thought. Even cosmic mysteries sometimes provide clues. One light joke drifts through the silence. The universe keeps hiding answers and then occasionally leaves one sticking halfway out from behind the couch. Still, the silence remains. And so your thoughts turn toward one of the most famous questions in science. If intelligent civilizations are possible, why do we not see evidence of them? This puzzle is often called the Fermi paradox, named after Enrico Fermi, who famously questioned where everyone might be. The paradox is not really a paradox in the strict logical sense. It is a tension between expectation and observation. Expectation says the galaxy contains enormous numbers of opportunities for life. Observation says the evidence remains frustratingly scarce. Many possible explanations have been proposed. Perhaps intelligent life is genuinely rare. Perhaps simple life is common while advanced civilizations are unusual. Perhaps technological societies tend not to survive for long periods. Perhaps civilizations lose interest in broadcasting. Perhaps they communicate using methods humanity has not yet discovered. Perhaps we have simply not listened long enough. Each possibility remains under discussion. None has been confirmed. And this is where the wow signal becomes fascinating. Not because it solves the puzzle, because it reminds us the puzzle exists. A single unexplained event can influence imagination for generations. Not because it proves anything, because it suggests possibilities. You drift through a region illuminated by ancient starlight. The photons around you began traveling long before human civilization existed. Some departed their galaxies before the first dinosaurs walked Earth. Cosmic time surrounds you, and time changes the way you view the silence. The Milky Way is more than 13 billion years old. Many stars within it are older than the Sun. Some planetary systems may have enjoyed billions of years of additional development. If even a tiny fraction produced intelligent civilizations, some would have possessed extraordinary head starts. Millions of years. Hundreds of millions. Perhaps more. The scale is difficult to grasp. Human radio technology has existed for little more than a century. Compared to cosmic history, that is barely an instant. A blink. A spark. A single heartbeat. You begin to realize something humbling. The universe may not be silent at all. Humanity may simply be listening during a very small moment. Imagine arriving at a concert hall after a performance has ended. The stage is empty. The audience has departed. The silence tells you nothing about the music that may have played earlier. Likewise, cosmic history stretches across billions of years. Civilizations could rise and vanish. Signals could appear and disappear. Entire chapters of galactic history may have unfolded before Earth even formed. That possibility introduces another layer of mystery. Not spatial distance. Temporal distance. Perhaps the challenge is not finding another civilization. Perhaps it is finding one at the same time. You continue drifting. Below you, galaxies slowly rotate. Stars are born. Stars die. Black holes merge. Planetary systems evolve. The universe changes continuously. Yet its largest mysteries endure. Dark matter remains unidentified. Dark energy remains unexplained. The origin of life remains uncertain. The fate of consciousness remains unknown. And the source of the wow signal remains unresolved. A pattern begins to emerge. Every answer reveals deeper questions. Every mystery opens into a larger mystery. The signal was once the center of the story. Now it feels more like a doorway. A doorway leading toward questions about existence itself. Questions about observers. Questions about information. Questions about whether intelligence is a rare accident or a recurring feature of the cosmos. Ahead lies an even quieter region. Not physically quieter. Philosophically quieter. A place where science approaches the edge of what it can currently explain. A place where facts remain essential but certainty becomes scarce. The stars continue shining. The galaxies continue turning. The signal continues echoing through history. And somewhere between knowledge and mystery, another question begins to form. not what produced the signal, but what it means that we noticed it at all. You continue drifting through the vast darkness between galaxies. The journey has become quieter now, not because the universe contains less activity. Far from it. Stars are exploding somewhere. Black holes are feeding somewhere. Galaxies are colliding somewhere. But distance softens everything. At this scale, even cataclysms become whispers. And among those whispers, one question remains suspended like a star that refuses to set. Why does the universe seem so quiet? The wow signal still lingers in memory. That brief burst from 1977 remains unresolved. Yet as you look across the cosmos, it begins to resemble a single drop of rain in a much larger mystery. Not the mystery of one signal. The mystery of cosmic silence itself. You float above a cluster of galaxies. Each contains billions of stars. Each star may host planets. Many of those planets likely formed billions of years before Earth existed. Some may have possessed oceans, some atmospheres, some chemistry capable of producing life. The numbers are astonishing. Even conservative estimates suggest that potentially habitable worlds may be common throughout the galaxy. That is one of the most surprising developments in modern astronomy. The universe appears remarkably good at making planets. And yet evidence for technological civilizations remains elusive. You consider one possibility. Perhaps intelligence is extraordinarily rare. Life itself may emerge relatively easily under suitable conditions. But intelligent life could require an unlikely chain of events. On Earth, simple organisms appeared very early. Complex multicellular life took much longer. Technological civilization appeared only recently. The path was neither straight nor inevitable. Countless species flourished without building radio telescopes. Dinosaurs ruled Earth for more than 160 million years without founding an observatory. One light joke quietly drifts past. Somewhere in an alternate timeline, a very confident dinosaur may still be insisting that radio astronomy is a passing trend. The thought fades. The mystery remains. Perhaps intelligence is uncommon. Perhaps technological civilization is even rarer. Or perhaps something else is happening. You continue onward. Ahead lies a region illuminated by the afterglow of the Big Bang itself. The cosmic microwave background surrounds the entire universe. It is an established scientific fact that this faint radiation represents relic light from the early cosmos, emitted roughly 380,000 years after the Big Bang. Every direction you look contains traces of that ancient epoch. The universe remembers its beginning, at least partially. Yet some chapters remain hidden. Scientists do not know precisely what occurred during the earliest fractions of a second. They possess strong theories, compelling models, substantial evidence, but uncertainty remains. Cosmic inflation, for example, is a leading explanation for several observed features of the universe. According to this idea, space underwent an extraordinary period of rapid expansion shortly after the Big Bang. The theory explains many observations remarkably well, yet the deeper cause remains uncertain. What triggered inflation? What came before it? Did anything come before it? Nobody knows. You begin noticing a pattern. The farther science advances, the more carefully it maps the boundaries of knowledge. Every solved mystery illuminates additional darkness beyond it. The wow signal sits precisely on such a boundary. Not ignorance, not understanding, a borderland between the two. You drift through ancient starlight. Photons pass around you that have traveled for billions of years. Some began their journeys before Earth existed. Some originated before the Milky Way acquired its current form. These particles have crossed cosmic time to reach your location. And that realization introduces another possibility regarding the silence. Maybe communication across the galaxy is harder than it first appears. The distances are enormous. A message traveling at light speed still requires years, centuries, or millennia to arrive. A civilization 1,000 light-years away would receive today's transmission 1,000 years from now. Its reply would require another 1,000 years. Conversations become geological events. Entire civilizations could rise and fall between exchanged messages. The universe may not merely be large. It may be too large for easy dialogue. This possibility carries a strange melancholy. Not loneliness exactly. More like separation. An ocean so vast that neighboring islands remain unaware of one another. You continue drifting. A black hole appears ahead. Not actively feeding. Not surrounded by a brilliant accretion disk. Just a dark object moving silently through space. Invisible except for its gravitational influence. It reminds you of another unresolved mystery. What happens at the deepest level of reality? General relativity describes gravity extraordinarily well. Quantum mechanics describes subatomic phenomena with extraordinary precision. Yet these two pillars of physics remain difficult to unify completely. Somewhere inside black holes. Somewhere near the Big Bang. Somewhere beyond current experiments. A deeper theory may await discovery. Physicists have searched for decades. String theory. Loop quantum gravity. Other approaches. Interesting possibilities exist. No definitive answer has emerged. The silence appears again. Not only among civilizations. Within physics itself. Nature reveals much. But not everything. You float beside the black hole. Its event horizon remains hidden. No information escapes from beyond that boundary, at least according to classical understanding. Yet quantum theory complicates the picture. The famous information paradox asks whether information can truly disappear inside a black hole. Many physicists suspect the answer is no. Information may survive in ways not yet fully understood. The details remain uncertain. And suddenly the wow signal feels strangely connected to these larger questions. Not because black holes produced it. No evidence suggests that. But because both mysteries involve information. A signal is information. A message is information. Knowledge itself is information. Perhaps the deepest questions in the universe concern not matter or energy alone. Perhaps they concern information and how reality stores it. The stars around you grow more distant. The darkness becomes softer. The journey slows. You have traveled from a black hole to a radio telescope. From a radio telescope to dark matter. From dark matter to cosmic inflation. From cosmic inflation to the silence of the universe. And now another question quietly emerges. Not where the signal came from. Not whether someone sent it. But what it means to search. What it means for a small civilization on a tiny world to listen for answers among the stars. That question awaits ahead. And it may be more profound than any signal itself. You continue drifting through the darkness. But now the darkness feels different. Earlier, it seemed filled with mysteries waiting to be solved. Now it feels filled with mysteries that may reshape the very meaning of understanding. The stars remain. The galaxies remain. The black holes, dark matter, dark energy, and the lingering puzzle of the wow signal all remain. Yet your attention gradually shifts from the objects themselves to something else. The act of asking questions. Because the deeper you travel into the universe, the more remarkable the questions become. Why does anything exist at all? Why is there a universe capable of producing stars? Why do the laws of physics permit complexity? Why can matter organize itself into planets, oceans, living organisms, and eventually minds capable of wondering about their own origins? You float between galaxies. Billions of light-years of darkness surround you. And somewhere on a tiny world orbiting an ordinary star, a species has learned to ask these questions. That fact alone is astonishing. An established scientific fact is that every atom heavier than hydrogen and helium was forged through cosmic processes such as stellar fusion and stellar explosions. The carbon in your body, the oxygen you breathe, the calcium in your bones, all were created inside stars. In a very literal sense, you are made from ancient stellar material. The universe eventually became capable of examining itself through you, through humanity, through conscious observers. This realization has inspired scientists, philosophers, poets, and dreamers for generations. Not because it solves anything, because it deepens the mystery. You watch galaxies rotating below. Each one contains countless stars. Each star obeys physical laws that appear consistent across immense distances. The same gravity that guides falling apples shapes galaxy clusters. The same quantum mechanics that governs subatomic particles influences the behavior of stars. Reality displays an unexpected coherence. A surprising observation is that mathematics developed by humans often turns out to describe nature with extraordinary accuracy. Equations written on paper somehow predict black holes, gravitational waves, and the behavior of light. Why mathematics works so well remains a subject of philosophical fascination. Some see mathematics as a human invention. Others see it as something discovered rather than created. The universe offers no definitive answer, only continued effectiveness. One light joke gently floats by. The cosmos somehow allows monkeys on a small rock to invent algebra and then use it to find black holes. That remains one of reality's more unexpected plot twists. You continue onward. The wow signal reappears in your thoughts, not as a radio transmission, as a symbol of curiosity. For nearly 50 years, people have debated its origin. Natural phenomenon? Rare astrophysical event? Something else? No conclusion has gained universal acceptance, and perhaps that is part of its enduring power. Mysteries often reveal more about the searchers than about the mystery itself. Humanity wants answers, patterns, explanations, narratives. A signal arrives from the sky, and immediately countless possibilities emerge. That response is deeply human. You search for meaning. You always have. Ancient civilizations searched for meaning in constellations. Later generations searched through telescopes. Today, researchers search through enormous databases, radio surveys, and observations spanning the electromagnetic spectrum. The methods change. The desire remains. You drift closer to a region filled with ancient galaxies. Their light has traveled for billions of years. Looking at them is equivalent to looking into the past. This is one of the strangest consequences of finite light speed. Astronomy is time travel of a very specific kind. You never see objects as they are. You see them as they were. The moon appears about 1.3 seconds old. The sun appears roughly 8 minutes old. Distant galaxies appear millions or billions of years old. The deeper you look into space, the farther you look into history. Time and space are intertwined. That realization reshapes many philosophical questions. What does now mean across cosmic distances? Does a universal present moment exist? Relativity suggests the answer is more complicated than everyday intuition implies. Time is not the simple, universal flow it appears to be. It stretches, contracts, depends upon motion and gravity. Near black holes, time behaves differently than it does on Earth. The universe is stranger than ordinary experience suggests, and still deeper mysteries remain. Some physicists wonder whether spacetime itself emerges from more fundamental ingredients. Others investigate whether information plays a foundational role in reality. Still others explore ideas involving quantum entanglement, holographic principles, or entirely new frameworks not yet fully developed. These are active frontiers of research, interesting possibilities, not established conclusions. The distinction matters. Wonder grows strongest when it remains connected to evidence. You continue drifting. The stars appear calmer now. The pace of the journey slows. And your thoughts return once more to the possibility of other minds. If intelligence exists elsewhere, what might it be like? Would it resemble humanity? Would it think in familiar ways? Would it experience curiosity? Would it ask questions about existence? Nobody knows. The universe provides only one confirmed example of a technological civilization. Every attempt to generalize from a sample size of one carries uncertainty. Perhaps intelligence naturally seeks understanding. Perhaps not. Perhaps consciousness itself is common. Perhaps extraordinarily rare. Perhaps minds emerge throughout the cosmos and spend their existence wondering whether they are alone. The silence offers no reply. Yet the silence itself may contain meaning. Not a message. A lesson. The lesson that uncertainty is not failure. The lesson that unanswered questions are not weaknesses in science. They are invitations. Every great discovery began as an unresolved mystery. Black holes. Galaxies beyond the Milky Way. Neutron stars. Exoplanets. Gravitational waves. Each spent years or decades on the frontier between speculation and understanding. The wow signal still occupies that frontier. Perhaps it always will. Perhaps someday a definitive explanation will emerge. Perhaps a forgotten detail awaits discovery in old data. Perhaps a new observation will reveal a natural source. Perhaps an entirely unexpected answer lies ahead. For now, the mystery survives. And as you continue drifting through cosmic darkness, another realization gently settles into place. The universe is not merely a collection of objects. It is a collection of questions. Some answered. Some partially answered. Some perhaps beyond current understanding. And among them, one brief signal continues to echo. Not because of what it told us, because of what it asked us to consider. You drift once more through the darkness where this journey began. Far ahead, the supermassive black hole waits in silence. Its presence bends space-time. Its gravity shapes the motions of stars. Its event horizon conceals a region that no observation can fully illuminate. It remains what it always was, a reminder that knowledge has edges. And beyond those edges, mystery begins. The black hole grows larger as you approach. Around it, stars wheel through the darkness. The galaxy glows softly behind them. Billions of suns. Billions of worlds. Countless stories unfolding beyond sight. Somewhere among those stars, nearly half a century ago, a radio telescope detected something unusual. 72 seconds. A brief signal. A handful of characters printed onto paper. A scientist's astonished note in red ink. Wow! The signal itself has never changed. The data remain exactly what they were. What has changed is everything around it. Humanity has discovered thousands of exoplanets, mapped the cosmic microwave background with extraordinary precision, photographed the shadows of black holes, detected gravitational waves, observed galaxies from the early universe, learned that dark matter appears to dominate cosmic structure, learned that dark energy appears to drive cosmic acceleration, and yet the source of the wow signal remains unresolved. That contrast feels strangely appropriate. The deeper your understanding grows, the more clearly you see the remaining unknowns. You arrive near the black hole. Light bends around its edge. The surrounding stars appear distorted. The universe itself seems warped. An established scientific fact is that gravity alters the geometry of spacetime. Mass does not merely move through space. It shapes space. The black hole before you represents one of the most extreme examples known. And still, physicists continue debating some of its deepest implications. Even here, certainty has limits. The surprising observation is that modern science often advances by becoming more aware of what it does not know. Ignorance is not simply erased. It becomes refined, more precise, more focused. Ancient observers wondered what stars were. Today, astronomers know they are enormous spheres of plasma powered by nuclear fusion. But now new questions emerge. How did the first stars form? What is dark matter? How will the universe end? Each answer opens additional doors. The hallway never seems to end. One final light joke drifts gently through the cosmic night. The universe may be the only place where solving one problem routinely generates 5 new homework assignments. You continue floating. The black hole remains beside you. The galaxy stretches beyond. Farther still lie billions of other galaxies. Each contains mysteries of its own. Some host supermassive black holes larger than entire solar systems. Some collide with neighboring galaxies. Some formed when the universe was young. The observable cosmos extends for tens of billions of light-years in every direction. Beyond that horizon may lie even more. Perhaps infinitely more. Nobody knows. And that uncertainty brings you back to the signal. What was it? A rare natural event? An unusual alignment of circumstances? A phenomenon not yet categorized? A technological transmission from elsewhere? Science cannot currently say. The evidence is insufficient. The mystery remains. That may feel unsatisfying. Yet there is something beautiful about it as well, because mysteries create movement. They inspire observation. They inspire patience. They inspire generations of researchers to keep listening. The wow signal matters not because it provided an answer. It matters because it reminded humanity to keep asking. You turn away from the black hole and look outward. The stars appear calmer now. The vast distances no longer feel intimidating, only immense. The universe has revealed extraordinary truths. It is older than anyone once imagined, larger than anyone once imagined, stranger than anyone once imagined, and still incomplete. The deepest questions remain open. What is dark matter? What is dark energy? How did the universe begin? Can information ever truly disappear? How common is life? How common is intelligence? Why does reality possess the laws it does? The list continues. Perhaps it always will. You realize that the signal's greatest legacy may not involve extraterrestrials at all. Its legacy may be humility, a reminder that certainty is precious, a reminder that evidence matters, a reminder that even in an age of remarkable scientific achievement, the universe retains secrets. And perhaps that is exactly as it should be, because a completely understood universe might be smaller in some important way, less adventurous, less surprising, less capable of inspiring wonder. The stars continue shining. The galaxies continue rotating. The black holes continue waiting in darkness. The signal continues echoing through history. And humanity continues listening. Slowly, patiently, hopefully. Not because answers are guaranteed, because the search itself has value. Because curiosity is one of the rarest and most remarkable things the universe has produced. Because somewhere between ignorance and understanding lies discovery. And discovery begins with attention. The same attention that noticed a strange signal on a summer night in 1977. The same attention that studies galaxies billions of light years away. The same attention that asks questions no previous generation could ask. The same attention that now drifts here, among stars and mysteries, looking into the dark. And listening. The darkness softens. The black hole recedes. The galaxy becomes a river of light. The river becomes a mist. The mist becomes distant starlight. And slowly, gently, the universe begins to fade into a quieter dream. For a while, simply drift. Let the stars surround you. Let the galaxies turn in silence. Let the black holes remain hidden in their ancient darkness. Let the quantum particles dance through empty space, appearing and disappearing according to rules that still challenge complete understanding. Let cosmic time continue its endless flow, carrying stars from birth to death, galaxies from formation to collision, and mysteries from one generation to the next. Imagine the earliest light of the universe still traveling. Imagine ancient photons crossing billions of years to arrive at distant worlds. Imagine future civilizations, wherever they may be, gazing upward and asking questions of their own. Perhaps they wonder about dark matter. Perhaps they wonder about black holes. Perhaps they wonder whether anyone else exists beyond their sky. Perhaps they too have detected a strange signal that appeared once and never returned. The stars shine. The galaxies drift. The black holes wait. Quantum particles flicker through the foundations of reality. Cosmic time stretches across ages beyond imagination. And through it all, the universe remains what it has always been. Partly known. Partly unknown. Endlessly beautiful. Endlessly mysterious. You understand far more than your ancestors ever could. Yet beyond every horizon, deeper secrets remain hidden. And somewhere in that immense darkness, the unanswered signal still echoes softly. Not demanding an answer, only inviting another question.